I know.
Oh, that would email you back.
Just that it won't actually get changed on the audit because I wasn't aware that it actually is a restriction that the registrar has, but no big deal. I mean, I told her, I said we've signed off on in the past of people who had a C- here and there, as long as they have the 3.0. So as long as we as a department sign off on graduation next year, they won't have a problem with it.
Because I know it was blank until I looked at it. And
Yeah, I didn't realize that. So
she's like, I don't have a grade.
Yeah. So that's all right. At least we didn't screw up on that like we did Jesse's. Yeah. But I can technically blame that on Deneen because she's your official advisor.
Oh, don't even.
So
you're the one that emailed me.
I know, crap, that email.
After I already had
when you said that there was an email, I was like, oh my god.
Because I purposely kept it in case something happened.
And I can't very well say, well, the form trumps the email because the form's right. That's just lying.
Because that was after
I can lie. The form trumps the email, Jess.
I already scheduled it, and you emailed me, and you're like,
sort of negates the lie when you're on video.
You don't need this, you need this. And I was like, but I already scheduled, Steve.
That thing is on, right?
Shh.
It's evidence now.
Tapes can be destroyed. Nothing's ever destroyed digitally,
So it's
right?
looking through our class history, like the video.
Oh, this is live streaming on YouTube.
Someone's looking through the D2L, and it's like, why is this dude missing the video for the day?
All right, let's do this so we get, because we're a little behind in class, and I want to get some things caught up, maybe.
Probably good thing I have a short introduction.
Good thing you're gonna have.
My name is Cody Huff.
That's how mine was.
I live in Renova, Pennsylvania, and I grew up here in Lock Haven. My major is secondary education with focus on mathematics. My advisor is Dr. Maynard. My fun fact was I attended elementary, middle school, and high school all here, like right in town pretty much at Dickey Elementary, right over there by Wise's. And then went to middle and high school here too, so.
Why'd you move to Renova? Who
Yeah,
moves to Renova?
I have family in Renova, so it's like,
Yeah,
still not
that is weird.
related.
Okay.
Don't.
There are only like 10 people in Renova. 3
I don't
are
wanna
Huffs
talk
and you're not
about
related? No. Right.
So I did the first standard for this, and Psych 201, Math 200, and Spec 202. We learned about different developmental stages, ways that people of different cultures develop their skills, even people with different in Spec 202. We learned different cultures and stuff. I don't really
His standards look a little different than yours because he actually used the new ones, which means I know he didn't start it.
Oh.
I did it last week.
I got you.
I started.
That's all right.
And yeah, the new ones were a little complicated.
I think they are,
especially with
yes.
the nets teas. I had some trouble finding artifacts.
Yeah, I wish we would have talked about that because I haven't looked at how the new ones are, so I'm not. Yeah, this will be a learning experience for me. So
there was a lot of different criteria that I don't know if I had to meet all of them for.
Yeah, I know. I don't know how.
It's like this standard and then part A, B, C, D.
Yeah, from what I've seen, I don't know how anybody would possibly meet those things.
Yeah.
Anyway, go ahead here.
But
learn development.
We learned a lot of different techniques for teaching, such as presenting things in different methods, such as visual or auditorial representations, and how well these work with students, not only based on how the students like to learn, but also what type of lesson works best in what format. So a math lesson obviously doesn't work that well in a kinesthetic format, usually, but.
So notice he doesn't have artifacts attached because we talked about it. He was not organized enough to actually keep his stuff.
I have a couple good artifacts.
Yeah, so he wrote
stuff.
things down.
Yeah.
Okay, so continue.
That is okay.
Well, in general,
For something.
no. I mean, you get to have as many hard artifacts as you can. But if worse comes to worse, if you don't have your stuff, you just describe what you did.
Yes. In Math 200, we hone these skills specifically in our mathematics teaching classes. like the things that we learned in Psych 201 that were sort of general. But, and then in 202, that was, like I said, we learned how to sort of incorporate those into different cultures for students, even like not only different countries, but like different regions, I guess I could say. Learning differences, we also talked about those in Spec 202 and Spec 212, which was, that was more of a, as low incidence disabilities, that's more dealing with things like the autism spectrum, physical disabilities, mental disabilities of any kind, social disorders. I don't remember these too well, I'm freaking out.
That's why you write notes down when you're giving us a speech or teaching a lesson, right?
We learned that from our oral communications.
That you haven't had yet.
Yeah, exactly. In Spec 212, we did practice a lot of techniques that helped with dealing with those like severe disabilities. Anywhere from like the mental ones, learning how to better plan your classes so as not to overwhelm any students that have sort of issues with that. And also physical disabilities can be extremely complicated, and we learn a lot of strategies to help assist those students so that we can get them into the class, like better incorporate them into classroom activities.
So I have two questions here. First of all, why did you take Spec 212
Just as a spec class, yeah.
And then you said, and you guys can enlighten me of what your spec teachers say, and we know in secondary ed programs we don't always agree with what your spec teachers have to say. But so you made the comment that you plan lessons so you don't overwhelm certain people with low incidence disabilities.
Yeah.
So now,
or just to better like, I don't know how to explain it, better plan around them.
Right,
Because
because certainly I would hope your spec teachers wouldn't say if you have because this is low incidence, right? So if you have a student that has, or if you have one student in your classroom, I would hope that they would recommend that you don't plan a lesson in a certain way that's going to meet needs of 20 students because it might overwhelm one student. I would hope that there'd just be some accommodation made.
Yeah,
where you would.
That's what I was. Yeah, that's what I should have said. Okay, accommodation.
All right.
I couldn't think of the word.
Yeah, I got you though. It makes. I like to know a little more about what they say because
Isn't a lot of what IEPs are for as well?
Yeah,
that's
what a lot of the class dealt with.
And the thing is, at the secondary level, fortunately or unfortunately, so many students get tracked in such a way that I know it's inclusion, right? And they're supposed to be mainstreamed in, but the truth of the matter is they end up getting they end up getting tracked and excluded
anyway.
instead of and they're in another class with other people that have these issues rather than being in our Algebra 2 classes and things like that. So the level of math usually ends up taking care of that tracking situation, and we don't end up dealing with too many people. I'm always disappointed in the fact that my secondary student teachers claim that they don't know what's on a student's IEPs because their teachers have not, or the teachers say, I don't even know what's on an IEP. That has to be illegal. If your student has an IEP, you should know what is on there. But at the secondary level, if the parent isn't highly involved in a kid's life and education, then that IEP sometimes gets lost in the shuffle unless the
That's really
student.
unfortunate.
It is. It's terribly unfortunate. It's just what I see out in secondary schools. It's like, oh yeah, there are 5 students in here. I know he has an IEP. Well, what does it say? I don't know. I've never seen it. Right? It's online. I mean, you go in and get it through the school stuff. So, all right, keep continuing.
Learning environments. Although we don't have much experience with this in any of our classes here, I think the best we probably get is in educational psych. we have a couple activities that we sort of worked with that topic, but most of my experience with it is from when I did go out and do my field observations. There was actually, because I've gone to Central Mountain, or not Central Mountain, Bucktail. Where did we go? Jersey, not Jersey.
You went to Belfont.
Belfont, and I went out to a school in Harrisburg over summer. I actually talked with, in the Harrisburg school, it was a math, for the MATH327. I talked with the teacher about why she had students grouped up into twos, and also, like in Bucktail though, when I observed, they did more big tables of like 3 or 4 students usually. So I got a chance to talk about that and see that, you know, depending on the subject of what you're teaching and depending on the size of the classrooms and stuff like that, you do get different dynamics of your class, like how you want to organize your classrooms. So
Where were you in Belfont?
just Belfont.
That was for observation.
That was for cultural diversity, wasn't it? Or no?
It's
Ashley,
Yeah, that's
Ashley.
Ashley. Yes.
Yeah.
Where were you? High school?
Yeah.
I
And
appreciate it a lot.
I didn't really talk about it with that teacher because it was like her and I think 5 other kids. So they kind of just
Yeah,
had one big table, which I mean, I guess that is also a environment.
Yeah.
And they all sat around her desk, so like it was easy for her to help with whatever. The next thing I did was 6 assessment. MATH327. Do you want me to pull up these articles?
No, there's no reason for it.
Alright. We did use our practice grade book. I use that as an example of using technology as an assessment as well. You know, we had to not only make up a grade book, but also use Excel's, like the way you calculate other cells to find our weighted means, and what was it called? Percent achievement?
Yeah, learning games.
Or learning game,
yeah.
But other than that, I haven't had too much experience with assessment.
No, it's block 2's
Yeah.
block 2's a lot of assessment stuff.
The last one I did was 7. Also MATH327. A lot of these came from MATH327. Oh, I do have a concrete example of this. I just figured out how to get it though because it was another doc.
Oh, another live text.
And I didn't know how to
Yeah,
but I got it now.
Yeah.
Was it? Oh yeah. Anyway, the lesson plan that we did for MATH327, I believe mine was trigonometric ratios, and that was just a good example of the first time that I ever got to practice actually writing out a lesson plan, thinking ahead of what I'm going to teach in a classroom and scenarios that are going to pop up, like students having a problem with some other ratio or calculator problems I remember we had in class. And then for my NetSteves.
Yeah, let's see what these NetSteves are all about.
Yeah. So facilitate and inspire student learning and creativity.
So was there a document attached?
I can literally Google it.
No, but you Google it, but I mean, was it attached to this? What do you mean Google it?
I looked up the NetSteve standards.
Right, but through Google, not on the other ones had it attached to the actual portfolio.
Did it?
There was no attachment to the portfolio?
It's like up top.
So was it
For
in the
you guys,
introduction?
Yeah, it was.
I just don't know if it was for you.
Because it was,
So
but
you
I got
Googled
rid of
it.
it because I thought that's where like I put my introduction and I thought that one was just there to
Yeah, okay.
hold the space for it.
Alright, well, I'll match these up and see.
Okay. I chose my What is Math essay because that was more of a abstract sort of thinking for math. I wasn't really sure how to incorporate this into NetSteve because most things we do are Word and Excel sheets, but I couldn't think of anything that really inspires creativity that we've done with technology so far. Like, whereas in other classes we've had like projects where we have to come up with some sort of creative project for them to do. It's usually not like technology based.
Right.
the closest thing I could maybe think of is something in GSP, but we've never really done anything like creative in GSP, I don't think.
Well, you need to go through, I mean, from what I remember of reading the new standards, I mean, those standards are correct. What I want you to do, because I'll remind you guys to turn in, or to fix up your stuff and then get them to me, you know, sometime in May. But you do need to, and I can't remember if the other ones did it or not, you do need to explain, in narrative form, explain why your artifacts for your NETS-T show that you're meeting the,
Like a rationale.
yeah, your rationale. Did you guys do rationale?
I did in mine.
Did you do rationale? So you just don't have any words there, so
Yeah,
you
for
need
the
to
next
edit that and explain. You do it
I
for
took
the other
another
ones.
section
Yeah.
and wrote all mine.
Okay.
Yeah, well, you don't need another section even. If you just hit edit, you can type underneath the table.
Yeah.
The table is just an insert, so just type underneath the table. Did you rationalize
No,
yours?
not-
You just
because
listed.
I didn't, yeah, 'cause I didn't know.
You just listed them. Just rationalize and say, for my first, just like you did above for each of them, you need to say, for my first art, or for my first artifact is a whatever it is, and it shows that I'm meeting the standard, whatever the standard is, because I whatever.
So it's like what's above, you just have to insert it into the section.
Oh yeah. So you would say, I chose my What is Math essay as an artifact to show that I'm meeting the facilitating, inspiring student learning and creativity because, you know, this is what I did in it.
Yes.
That's all.
Basically what you
What's
said
that?
in your presentation,
Yeah.
just put it in Word.
Yeah. Something like within the essay what we should.
Is that right?
Yeah, I'll need to check that. Since you use that, you'll have to be my guinea pig as far as I need to figure out the new standards and stuff anyway.
And we don't need to do the right side.
No, the in-test standards, no, don't do that.
Oh, we don't.
No, because that's actually, for the old, that's actually done in a document for you already, so I don't see why they need to repeat. So there's a document that's attached that says, if you chose this NETS-T, then it goes with these in-test standards. So it's really stupid to do that. For the new ones though, we are still working on, somebody just threw this new stuff at us last month and we haven't sat down and figured out what the heck it is. So so I'm not too worried about that right now. So
Design and develop digital learning experiences and assessment. I used my GSP trig lesson because we used GSP to develop that lesson. Model digital age work and learning. I used my practice grade book for this because I thought, you know, as a teacher, this is what I am going to be doing a lot of the time, is using Excel in my workplace as sort of a way to organize grades, or some sort of data sheet format to do stuff like that. This standard I had a lot of problems with. The promote and model digital citizenship and responsibility. A lot of the criteria for meeting it said that we should encourage and model using correct like etiquette on the internet, like trademarks and stuff. And I couldn't think of any like concrete examples of that. So I just
that's why I think we have some issues in the education unit itself, that with these new ones, I think we threw these ones on students and we have not put in place much to figure out what it is we're doing, so we're gonna figure that out.
My rationale for choosing Psych 201 and Psych 212 though, where in those classes we do a lot of researching and using like articles from other like sources, so I thought like this is the best example of like respecting trademarks and digital.
Yeah, that's why it's important to provide a rationale and explain why, because you know, as long as you can explain why you think that as you're reading it, you know, the benefit of the doubt always goes to the person explaining it. It's like, okay, well, if they think they're reading it this way, who am I to say they're not?
No.
But, yeah.
And then for engage in professional growth and leadership, I chose my trig lesson personal reflection because after we were done with the lesson, we were supposed to watch it again and reflect on what we personally felt we did wrong and compare it to like our grade beyond the set.
All right. So what did you think? Just in closing here, what article or what standards do you think you felt pretty comfortable in that you're starting to meet, and which ones do you think you're still weak in?
A lot of the inclusion, anything that really involved inclusion, I felt like I had a decent grasp on because I've had like that Spec 212 class and the cultural diversity class, so
we did learn a lot about just like the wide range of students that you could possibly deal with. So I felt really good about anything involving inclusion. The NEDSD standards of the personal reflection, like engaging personal or professional growth. I thought that, you know, we have done, especially recently, like in our newer classes, we've done a lot of like personal reflections on things and stuff like that. So.
All right. Well, yeah. I mean, that's why I was kind of hoping that everybody had already started there, so they could use the old, and I could figure this out in the summertime. But you know, at least forced me to figure it out earlier. So
Yeah, I started it like last week.
That's good.
I told you, Steve.
Well, listen, I can't do mine anyway. Like, the reason I didn't is because I can't do mine anyway until I get my 3.0. So,
Yeah, which hopefully you'll have after this semester, right?
we'll see about that before.
I think we'll be.
Abby's killing
We're
us.
smarter now.
We'll be fine.
Yeah, seriously.
I'm confident in it.
Killing us.
Justin had to be very good
I think
at
you'll be fine.
Yeah.
I think it'll be fun too. Okay, so let's just roll here. I don't even know why I'm opening that up. Let's just roll here. Let's get out number 6. So if somebody asked you, and be honest and answer this question both before and after you did any studying here. A, have you ever thought about this? And B, so I'm on page 33, and B, how would you have answered the question, how are Pythagorean theorem and law of cosines related? Now, also, I did address this, you know, in geometry, you know, and you may or may not have remembered it. Obviously, it's this much of a, you know, a big course. But in general, though, like, how would you have answered it? Would you have been able to answer it before delving into anything that you looked up in a textbook or online or anything? No, you wouldn't have been able to. Would you have been able to?
I didn't remember law of cosines. So.
Just didn't even remember law of cosines. Okay, but that's good. But that's good. That's honest. And one of the reasons is because, you know, law of cosines you get in a trig class.
Mm-hmm.
And unfortunately, even with our better students mathematically who are going to go into math fields, yes, you might take trig and pre-calc and even AP calc or something like that in high school, but it's that stuff is not the focus of the curriculum. You know, algebra, getting everybody past the Keystone exams, and that is obviously too much of the focus on there. You were going to say something.
Yeah, I was gonna say that I remembered, you know, that I connected the Pythagorean theorem with, you know, finding the side lengths, and I knew that the law of cosines had something to do with angle measurements.
Okay, all right. So you at least knew that. I mean, Pythagorean theorem. Okay, boom. Finding the side lengths of a right triangle, right? But we know that's right triangle. A squared plus b squared equals c squared.
Yeah.
You might remember law of cosines has something to do with finding sides, but needing an angle.
Yeah.
You know, something like that. Yeah. So let's look at our, what is that, number 6. So first thing I want to say about that is this. We look at the Pythagorean theorem. Okay? Pythagorean theorem is a relationship. Now, notice I am not starting out with the Pythagorean theorem is a squared plus b squared equals c squared. I don't give a rat's behind what the formula is because I don't even know what a, b, and c are. Okay, just a squared plus b squared, c. Everybody can recite that, but nobody knows what it is. So I'm giving it to us in words here. Okay, the Pythagorean theorem is a relationship among the side lengths of a right triangle. Now, I might say this. In other words, we can use it to do what we call solving a triangle. So this is one of these Pavlov's dogs. When I say this, you start salivating, you know, type of things in mathematics. To solve a right triangle. I put that in quotations because, you know, solve this right triangle. What that means to us in math is find the missing parts. Okay? Now, technically to solve a right triangle, or to solve any triangle, you would say, I want to find all the sides and all the angles, but if the question only asks for solving the sides, or finding the sides, then you're solving for the sides, okay? So that's one thing. So now, obviously, we know the relationship, and it looks like this. The C is usually the side, or the 90-degree angle, so that's the opposite, big A is little a, B and C, so on and so forth. We say this, the relationship looks like A squared plus B squared equals C squared. Now, I would never let anybody say A squared plus B squared is C squared unless they can also tell me, well, what the heck is A, B, and C? Right? Keeping in mind that A and B are the side lengths, and I can get away with saying side lengths because even though this is a side of a right triangle, we don't call it a side because it has a special name, right? Hypotenuse. All right, now, the second thing to make sure we get is this. The law of cosines is a relationship among the side lengths and one included angle. Right now, included angle doesn't really matter because I'm talking about all three side lengths. So all three side lengths are there in this law, but one included angle being between the two, between any two sides. Relationship among the side lengths and one included angle in an what we call oblique triangle. And when we say oblique triangle, we just mean non-right. Okay? It's just not a non-right triangle. Now, again, I would say this is used to solve a triangle. Okay, used in at least in part, or to solve in part, used to solve in part a triangle. Now, it looks like this. You looked it up, right? Yeah. It looks like this. Well, and I'll, I guess, draw the triangle here, right? And if I have a triangle that I want to draw like this, it is not right. So I would really put A here, B here, and C. And I do this. I form it this way. It doesn't really matter how you form it, because, you know, and maybe it's this is certainly tradition and it makes sense and whatever, but we usually put C as the right angle, and so that's why we then say A squared plus B squared plus C squared. Well, you know, I didn't learn A squared plus B squared plus C squared. I learned leg 1 squared plus leg 2 squared equals hypotenuse squared. And that to me is far superior to it, because then I don't care where the A, B, and C are. I think A squared, B squared, C squared has led to a lot of confusion with, well, I have to have C as the right angle. Well, you don't have to, okay? Traditionally we do. 98% of the problems you'll probably see are C with the right angle, but it doesn't matter. It's what are the legs and what are the hypotenuse, okay? Anyway, so over here, it certainly doesn't matter because there's no right angle. But still we would have A is always, little a is always opposite, and little b and little c, okay? Now, given a triangle like that, I label my non-right triangle this way because for me as a teacher, this is how I prove this or derive this formula, but it doesn't have to be, only because the first way we see the law of cosines is this. We would say that, and I'm going to write it because I'm going to write it in a way that's going to help us see a connection, but it's not necessarily the way that you see it the first time you see it. What I mean is, I'm gonna write it like this: a squared plus b squared, and everybody starts salivating when I write that, and you say, oh, he's gonna write equals c squared. But a squared, I picture little dogs running around, you know, going, oh, I know what he's gonna do. A squared plus, like my dog when I come home. He's gonna pet me. A squared plus b squared minus 2, these two, ab, times the cosine of the one that's not there. Okay, if I want to say the letter that's not there, but I can't put little c because little c is a side, so it's capital C, right? Equals c squared. Now, if you, for those that looked it up, well, it's not a fair question because of how I answered this here, but if I was creating a lesson and I wanted to just put the law of cosines up, I might say, hey, anybody see anything in there that looks kind of familiar? And I'm trying to see if anybody sees. Of course, you're all going to say, oh, I see the Pythagorean theorem in there. And no, you don't if I didn't, put my question like this, if you were a typical, trig student. And this is why we don't see the connection. This is why a lot of teachers don't see the connection and therefore don't talk to their students about the connection, is because where is that taught first in the curriculum? Give me a grade level that you think you learned this.
6.
Okay. Upper elementary, definitely 7th grade, right? But I'm going with probably 6th grade. You're seeing that. All right. Where do you see this? Did you ever see it in high school?
10th.
You remember it?
Yeah.
Okay.
Probably, yeah.
10th,
11th
grade is a little weird because it's usually in what kind of class though? You say 10th, but what do you remember? You had trig, right?
Yeah.
So 10th or trig could be 10th, 11th, 12th, whatever.
Trig nowadays is probably like non-existent.
Yeah, well, trig pre-calc, this is where you see this.
Yeah, based on how all the schools are tracking, they have like algebra going to like 10th grade, so then you have your geometry that you choose between calc and trig.
Right.
So I think it's not even fair anymore about trigonometry.
Yeah. I mean, unfortunately, that's a lost kind of a, that's a curriculum argument, I guess, that we're not going to fight here. But,
Yeah.
Well, so now keep in mind this, that this, another way that this could be written, because none of those are special, okay? Those are special over there. It has to be leg squared plus leg squared equals hypotenuse squared in that form. Over here, though, I could write a squared plus c squared minus 2 ac cosine, right? So I could say a squared, and it doesn't matter what the equation looks, or what the triangle looks like. I could write a squared plus c squared minus 2, those two, times the cosine of the one that's not there, a, equals, equals little b squared. And again, the third way as well. But I'm not here to solve triangles, I'm here to make a point. So, the third thing though, let's see. Yeah, we'll put it up here, I guess. The third thing that I want us to see though is this, is if we let the measure of angle C equal 90 degrees in the law of cosines, what do we get? We get the what?
Amount.
If we put 90 there, what's the cosine of 90? 0. This is 0. A squared plus b squared was c squared. Now the reason why your teacher probably didn't connect the two is because maybe they didn't see the connection, but it's because he was a trig teacher, he was an 11th grade teacher in general, so an 11th grade teacher, and he just assumes everybody knows the Pythagorean theorem, and he's never actually taught the Pythagorean theorem for the first time because that was 6th grade. Okay? He might teach algebra 2, even algebra 1, but at that stage you're like, you've seen the Pythagorean theorem in 6th grade, so this is what it is, review it a little bit, you don't do anything else with it, geometry, whatever. But there's a disconnect there in the time period. It's from 6th grade to 10th grade or 11th grade, and it's like, why would I make that connection? I don't even see the connection because I don't, they're not together in the same chapter, section, whatever. So we get the Pythagorean theorem if we do that. No, I'm not going to write it up there. You can see 0. So what I want to say then is this, is therefore, so this is really the key to the answer to the question, how are these related? I could say this then. Couldn't I say that the Pythagorean theorem is a special case of the law of cosines? Or I can say the law of cosines is the general form of the Pythagorean theorem. But that's the connection between the two that we need to make sure that we are aware of when you become, you get your first job and you're going to teach trig, and you've got trigs and calcs, you've got algebra 2 and trig, you got and you're not a middle school teacher or whatever, and then all of a sudden you got to teach a law of cosines. Well, related to something, okay? Related to something. It is the solving of a triangle. It's all solving a triangle. These are all strategies, law of cosines, and then there's a law of sines too. We're not talking about that here, but there's a law of sines as well. These are, and I don't want to call them trig relationships. I just want to call them all relationships among sides and angles in a triangle, right? They're just relationships. Yes, some of them involve trig functions, sines and cosines, all right? But they're just relationships that I teach that will give me tools to find missing sides and angles of right triangles, or of any triangle, okay? Whether it be right or oblique. Now, the last thing though is this, that the law of cosines, because this is something that I think we ought to be able to do, we should be able to do this with law of sines, law of cosines, quadratic formula, and I say, I lump the law of cosines and law of sines in here, probably not, like with the quadratic formula, probably honestly not fair to you, having been brought through the K-12 system in the last 20 years, but I lump them together saying that teachers, we ought to be able to graduate undergraduate program being able to derive these. And those aren't the only three things, but at least these three things, because they should be so commonly used that we know how to do these things cold. Okay, maybe that's fair to say for me, 30 years ago, I still remember going into my methods classes senior year, and my methods teacher gave us this test, and it was I don't know how many it was, but it was basically an upper level kind of a high school test, and a lot of it was deriving these things and proving these things, and some of them were deriving the law of cosines, deriving the law of sines, and I did it. I mean, I knew how to do it, and that was going into the methods class. But again, things were a little different there, and that was more the stuff that was focused on in high school, not just algebra. At the same time, don't get me wrong, I would never adhere to the thinking of some that would say, we did things so much better back in the 80s. We were so much more prepared back in the 60s. Schools were better. That's not true, because maybe it was for me. Maybe I, as a top math student in my high school, came out better prepared for college math than you did. We also left a lot of kids behind that we don't leave behind today. So it was more of, who cares about the ones down there? And my algebra class was taught that if you didn't catch it, so what? You're going to consumer math. You're going to business math. I'm going to algebra 2. I'm going to, so, you know, teach me, I catch it, boom, I got it, and I was a great math student in, you know, high school. Yeah, we just don't do that anymore. I don't know necessarily which one's better or not, but it's certainly different. You know, so it's not like it's, you know, it's not like that was better. You know, what's the saying? I heard somebody say, I didn't coin this, but you know, people are always saying, like, you know, today, man, times were really tough today, and they might say, you know, man, money's tight, and you know, I heard somebody once say, times have always been tough, and money's always been tight. Okay, it's not like you can go back to the good old days of 1950. Times were tough in the 50s, and money was tight in the 50s. You know, it's just the way it is. So people who, the older adults in your life that say, you know, things were so much better, you know, back then, I don't buy it. Anyway, the law of cosines is derived. In fact, I think you have it a little bit. We know more today, so I think that you know, you have a better opportunity today as long as you take things. So the law of cosines is derived from the, how about using the, derived using the Pythagorean theorem. So what I mean is, let's derive this thing. Here's my A, here's my B, here's my C, and this is something that we should be able to do cold, and we should be able to, now, we do it cold not because we memorize anything, because, you know, not very, sometimes, yes, this happens, we start playing with something and out pops a formula, but for the most part, we should understand the formula. So I understand what I want. I want a squared plus b squared minus 2ab times cosine of c equals c squared. That's what I want, okay? So I'm thinking about it in my head as a teacher. So I'm not trying to memorize this. What I'm going to do is this. Or I want it in one of those forms, because let's say I do this in class and I accidentally put A here and C here and B here, okay? Well, if I do that, then my formula is going to be screwed up, but it's still going to be one of them. It may be a squared plus c squared minus 2ac times the cosine of b equals b squared, but it's going to be one of them, okay? So what I mean is this. Obviously, this is A, this is B, and this is C. Now, in my head, I see my triangle like that, and what I do is I say, I'm going to derive the law of cosines, I drop a perpendicular. Now I drop perpendicular because I know why, not because I memorized drop perpendicular, because I know this. I know that this is an oblique triangle, it's not a right triangle, all right? I know that the law of cosines is a generalization of the Pythagorean theorem, and I'm going to use the Pythagorean theorem to derive this thing. So I got to get some right triangles. So I drop that to get a couple right triangles. It's an altitude. I know I call that an h. And here's the thing that I have to make sure I remember, is I need this part and that part, okay? Well, call one of them x. Call that x, therefore this is what? A minus x, okay? Now, then in my head I say this. I need A's, B's, and C's in my equation, right? But when I look at this triangle and that triangle, and think about the Pythagorean theorem, they're going to have h in it. Well, here's what I'm going to do. But both of them are going to have h in it, right? This one's going to have h in it. This one's going to have h in it, right? What I'm going to do is, I'm going to get this one solved for h, and really just solve for h squared. This one solved for h, and this one solved for h. If I put those two together, then h is gone, right? And I've gotten the h out of here. Okay, right? So that's what I'm going to do. So, what's that?
I just got
I think
that.
that's funny. So what I'm going to do is this. I'll look at this and I'll say x squared plus h squared equals b squared. Got it from that left side, right? And what? For here, a minus x squared plus h squared equals c squared. Now I know h has nothing to do with my formula. So I will say h squared equals b squared minus x squared, and h squared equals c squared minus a minus x quantity squared. Now, I know this too. X is not supposed to be in my formula either, right? Well, that's good because that's x squared and that's x squared. Negative and it's going to be negative. They're going away. So this equation is not going to have x squared in it at all. But it is going to have an x in it. And I'll have to deal with that in a minute. But wait a second. It's going to have x in it. But I know that it also has a's, b's, and c's. But I also need cosine c. But look at x. The cosine of c is x over b. Right? Which means x is going to be something in terms of b and cosine c if I solve it. So I have a substitution that will get rid of x. Okay, so I set b squared minus x squared equal to c squared minus a minus x quantity squared. Make sense? If this equals h squared and this equals h squared, then these two things equal each other. These are the things that you really ought to. I'm not saying modern algebra, linear algebra, those things aren't good and that, but these are the proofs, derivations that you really need to walk out. That's why I have these classes, because this is the stuff that you really need to be able to do walking out of there. Doesn't matter that you can do some of your number theory stuff and all that. Yeah, that's important too, but this is probably more important for teaching secondary math. All right, so let's do some algebra here, right? So what do we got? C squared, and then minus a squared, and then it's going to be a minus 2ax, but then a minus, so it's going to be plus 2ax, and that's going to be a plus x squared, but there's a minus, so minus x squared. X squares are gone, that's good, and I'm getting really close, right? Now, I do have to remember, and sometimes I forget, it's been a while since I've done this, I do have to remember to call it A, B, and C if I want to make it a squared plus b squared, some stuff, equals c squared. Otherwise, it's going to come out to be one of the other ones, which is no big deal. Then I just say, well, look at the, if I mess up there, if I have to do a cold and I didn't think about it or make a mistake there, I might get b squared equals the things, and then I just say, okay, well, just look at it, because what it is this. If this is my angle, I need to know these two sides and the included angle. So it's going to be this squared and this squared minus 2 times these two times the cosine of the included angle equals that one. So it doesn't really matter which one it is. Anyway, all right, so what that means is I have b squared equals c squared minus a squared plus 2ax. Now, at this point, it doesn't really matter what you do. If you want to start getting it in a better form, I would probably say, at this point, I would just say, but cosine c equals x over b, so x equals b cosine c. Right? Thus, what do I have? B squared equals c squared minus a squared plus 2a, what's x? B cosine c. So now, this isn't in the normal form that you do, that you put it in, but keep in mind from, what did the one that we did with the multiplying like bases, right? Can you add or can you multiply the bases, right? Multiplying like bases where you add the exponents. Can you well, yeah, you can. It just has a different formula. So even though we usually see this as being what? It'd be c squared, so I'm going to leave it on the right, but I'm going to write, what I'm not going to take all this stuff over here. I'll take that over and have a squared. Your b squared's over there. Take all this, and it's minus 2ab cosine c, and that equals the c squared. And I got it. While that's how I usually see it, I can use it up here to solve for b if I know c, right? Yeah. So it really doesn't matter, what it is. Usually, if I, so I guess I say I need the included angle, but that's that's in the traditional normal format, right? So what I mean is, I could use this to solve for B, right? I could use this to solve for B, that's this angle here, if I knew C and A, right? So if I knew the other two sides, so I always have to know two sides, like the Pythagorean theorem, right? So I need two sides, but then because that A and well, that's not entirely true, because B is here and B is here. So what I was trying to say is not entirely true, right? So it's not. What did I say that? Yeah. So I can't use it to solve for B. Which, you know what? I'm going to take that back. That's not entirely. You can, because when you get into the harder problems, because now I'm thinking of the last time I've taught some good trig. When you get into the harder problems, you can, if you knew C and A and then the angle C, you just get a quadratic. You just have to solve for quadratic. It's not the traditional ones, but you just get the B squared, some numbers, right? This is a number, this is a number, this is a number, and that's a number. So what's your final equation that you have to solve for look like? Instead of B squared equals 16, and therefore B is 4, because it can't be negative 4, right? What do? You get B squared equals, let's just say that number comes out to be 5, and that number comes out to be 3, and then plus 2 times A, what did I say that was? 3, so that make it 9. So 9 and 25. And then that's 3, so 3 times 2 is 6. It's 6B times the cosine of an angle, so whatever that angle is, let's say it changes that to 3, okay? The number changes that to 3. Then what do I have here? Well, I just have a quadratic, I have to solve for B, right? So I don't have to have the included angle. Traditionally, that's how it's set up, but all I have to have is an angle and 2 sides, and then I can use it, that way. So, yeah. All right. Well, we need to just catch up on Tuesday next week. So 7 and 8, I don't want to do anything else. We will finish 7 and 8, and then between my department meeting and then
we could just do what I said for 7.
Well, and 7 should be super easy because of what we did before. 8 will require a little bit of thinking.
Yeah, I know, right?
As to why does that work? But if you think carefully enough, then let's just get those done, get caught up to where we're actually at as far as our homework goes, and then we'll move on from there. Developing portfolios in a department meeting kind of killed me.
Talking about the new standards took a little bit of time.
Yeah. Well, you were still only 15 minutes.
Yeah.
So we started early.